Hello, my name is Marco Kulicke, and I work at the Data Management Department of the German Climate Computing Center. In this presentation, I will give you an overview about our NFDI for Earth Incubator project on how to implement an IPFS pinning service for open climate research data. First, I will tell you which problem I will address. Then I will give you a background on the IPFS. Later, I will explain our proposed workflow, and in the end, I'm going to present our results. Currently, we are facing mainly two problems. The first problem is that we usually get to see the data of our researchers at the very end of the project, and we have little to no possibility to assist with our data management. This can lead to insufficient data management, including subsequent and unrecognized data changes, or even permanent data loss. We are hoping that we can mitigate these problems by using the interplanetary file system, which I will call IPFS in the following. IPFS has been developed since 2015 as open source peer-to-peer storage network for sharing data in a distributed file system. That means, unlike the top left picture, which you see here, the data is not hosted on one server, but instead on various computers which are all equal. Another important factor for us is the concept of content addressable storage. That means, unlike location-based storage, content addressable storage makes the data immutable, and this means data cannot be changed. This is done by assigning to each block of data a content identifier, which is called CID, which is basically a cryptographic hash. Due to the peer-to-peer network technology, the IPFS is fault-tolerant and can ensure workflows even if individual components fail. By definition, the IPFS is a public network, and this is one of IPFS' core strengths. At its most basic, it's essentially a global distributed server of the network's total available data. This architecture strengthens open science efforts. Before I present the proposed workflow, I introduced the concept of pinning. The IPFS network can protect data from being deleted by pinning them. There are two options. The first option would be local pinning, where you pin data to a local computer. The second option would be a remote pinning service. The aim of the Incubator project is to provide a remote pinning service, which is especially useful when you don't have a lot of disk space, but you want to ensure your data sticks around, or you're working on a laptop, phone, or tablet that will have intermittent connectivity to the network, and you still want to be able to access your data on IPFS from anywhere at any time, even when the device you edited from is offline. And another use case is if you want a data backup, which is always available from another computer on the network, even if you accidentally delete the original data source. How does our proposed use of the pinning service look like in practice? Step 1. The researcher downloads the IPFS desktop app. This is fairly easy and is explained within the GitLab repository. Second, the researcher adds the dataset pinning service API endpoint to the IPFS desktop app. Step 1 and Step 2 only need to be applied once. Then, whenever the researcher wants to secure, that means to pin data, the researcher simply needs to add a pin in the IPFS GUI to the data which should be secured, which you can see over here. Of course, the pinning can also be automized via the command line. In the end, the researcher has two advantages. The data is available anytime, and the researcher knows that the data is immutable. Which outcomes did we achieve within the project period? We implemented an IPFS node on a virtual machine within the dataset infrastructure and made it accessible from the outside anytime. There's a limited amount of disk space allocated to it, which is roughly 10 GB at the moment, but it can be extended up on demand. Currently, the files need to be pinned manually via the command line interface. The scientist needs to share the CID of the data with us, and then we can pin them. We perform tests with various file types and sizes in order to test the practicality of file sharing via the IPFS. These include simple text files, netcdf files around 200 MB, and xArray files between 200 MB and up to 12 GB. Here we see an example of an IPFS file access. So we simply open the file with the xArray library, and the file is identified via its unique content identifier, which you can see here on the right side. Immediately after, we are able to read the metadata of the file, such as the size, the shape, the variable names, units, etc. The file download starts when accessing the value of the file, which happens if we start a calculation or start plotting. Then also the actual file data transfer starts, which you can see on the right-hand side. On top we see the network traffic of the receiver, which would be the scientist, and below we see the network traffic of the data provider, which would be, for example, us, the German Climate Computing Center. With this, I would like to close the project overview. Further information can be found in the repository and the application tutorial video. Thank you and goodbye.